So let's kick things off, get the conversation started, if you would. Provide a little background, if you would, on the mission of the Department of Defense CyberRange and a bit about your supporting role in it.
I am Ernest McCaleb, and I am the lead architect of the DoD Cybersecurity Range. We are a DISA-funded project whose primary mandate is to offer an operationally realistic environment to warfighters all across DoD, cyber warfighters in particular. It's a place where they can practice tactics, techniques, procedures, force-on-force training, product evaluation, pretty much anything you can do, you would do on a production network if you were allowed to do nefarious things. You come to our environment, you can do it, and best of all, we are 100% free.
Excellent.
Yes. Yes, not a misstatement.
Free's great.
Yes.
Yeah. Kevin?
Jason, thanks for having me here. I'm the founder of Cypherpath, along with my co-founder here, Art. And Cypherpath came about from a very big problem that we were trying to solve for about 20 years in the training industry. We had people who wanted to have the real skills needed to solve real-world problems within DoD, civilian agencies, and NSA, and some other organizations. The challenge we had was setting up this infrastructure and tearing it down for everybody to get hands-on instruction. So a group of thought leaders came together and figured out how to solve this problem. So we created something we call infrastructure containers and infrastructure as a file. What we wanted to do was eliminate the heavy lifting of bringing up infrastructure, tearing it down, and resetting it over and over again. So I was brought into the CyberRange. We called CyberRange 2.0. I worked with Ernest and his team, and the use case was we need speed. We have to do a lot of customization to these environments. A lot of the challenge was there's physical infrastructure involved, so reconfiguring, setting it up, tearing it down, way too much time spent on that. Isolation, because we're going to run multiple events where we want to have these environments running with malware and attacks going on, and we want to do this across a large cluster of machines. So I was brought in to solve this problem. And the last piece was we needed to have scale and to scale to any workload. So our challenge that we had to solve was how do we make this extremely scalable from the smallest scenario to this massive scenario that would take place in the CyberRange.
Good. Thank you, Kevin. Appreciate that.
Sure.
So Ernest, what are some of the biggest challenges that you and ManTech have faced at the CyberRange?
A CyberRange is very difficult to maintain because it's going to be multi-tenant. However, you have cyber warriors whose natural inclination is to break out of a box. So when you try to put or you try to isolate cyber warriors into an event or into a range, it's very hard to contain that. However, just for a little advertisement, we supported 172 missions last year. We're on our way to supporting a little bit more than that this year. So we're growing, we bring customers in like crazy. So the idea was, okay, to solve this big problem of multi-tenancy, and humans are good at doing things once. We don't want to keep repeating the same thing. We want to build infrastructures, roll them back, put them aside, and bring them back as required. I'm not talking about individual VMs. I'm talking about entire environments, network, compute, storage combined. So these were kind of things we were trying to fight to try to solve. Cypherpath became an organic solution in that respect. As like we will define, it is completely infrastructure as a file. We can now save entire environments, roll them out as required. This is particularly important when we are going to do classroom type training. You have 30 students, whatever, you make that one environment, you literally copy the entire environment 30 times. That's much easier than trying to segregate a typical hypervisor environment.
That's great. Thank you, Ernest. So, Kevin, there's a lot of cloud technologies out there today.
Sure.
From private cloud to public cloud technology. So what makes Cypherpath different, and why Cypherpath at the DoD CyberRange?
Sure. Another huge problem we had to solve was there's a ton of legacy infrastructure that's out there. We're not here to displace that infrastructure. Look at VMware, look at Red Hat, look at Microsoft. On the other hand, there's new services, microservices such as Docker, CoreOS, Kubernetes that are coming into play. So how do we bring this together holistically? We believe this world's a heterogeneous world, and we have to have all those operating together. So we set out to work with this legacy infrastructure and modern infrastructure and put it together, what we call an infrastructure container, where it's isolated and it runs over and over again as one single unit of compute. What we're doing is we're converging together compute, network, and storage as one app. So we worked in the field of software-defined networking, embedded that technology into what we're doing. We embedded hypervisors. We embedded some very unique technology in there to eliminate this heavy lifting. And at the end of the day, one of the bigger problems that we're trying to solve is the skills it takes to set this up. So we created what we believe is a zero skills software platform where you can develop and build this stuff pretty much instantaneously and deploy it. So our goal is to work with everybody in the market, not to be, not to take out our competitors, but to make it easy to orchestrate provision and work with all those types of technologies.
Yeah, I heard instant and easy in there, which certainly does remind me of a single-serve coffee machine.
Yeah.
Right? Absolutely. Yeah. It's good. So Ernest, what are some of the biggest design challenges that you were faced with at the range around scale and speed? And
One thing is to understand that the way Cypherpath is, the way it's developed, you can't just use a typical VMware or ESX type of backend. You need to be very, very flexible in the backend. And there was a lot of lessons learned for us, and there's still lessons learned for us about how to properly architect it. However, we know one thing: we do need a lot of speed and flexibility on the back end. One thing about it, and we don't call anybody's baby ugly. Everybody has a wonderful product. It just has a niche. So what we tried to do is find, okay, so what is the product that works best with his hypervisor, with Cypherpath? And what we determined was, in the fact of Tegile, the fact that it was a very open, the fact that it had open APIs, the fact that it can do block and NFS, so file level storage as well as block, was very advantageous as it corresponded to using Cypherpath. So the pain points, once again, and what the challenges are, et cetera, we'll continue even to flesh that out. We're evolving as a range. And one thing I'd like to harp on as well is that the need for physical infrastructure will probably never go away in a true cybersecurity lab, because you don't want to become too much of a model in SIM. That always seems to be a deficit for the warfighter. You have to be able to incorporate legacy. You have to be able to meld the old and the new. So we're pushing forward. We're trying to evolve. We're trying to host as many people as we can. We're trying to be an asset to all of DoD. We're trying to grow further. And so within that, we are finding the best way to do things. We're getting there. We're working hard. And with your help and your help, we'll probably get there eventually.
Yeah, and expanding your services, and I know a rapidly growing portion of your business now as well is all around CDM.
Yes.
And Homeland Security, and we're all very familiar with that program, and with the civilian side of the federal government as well.
Yeah, we're trying to go everywhere.
Yep,
It's
right on.
ManTech, yeah.
Good, thank you, Ernest. So Kevin and Ernest and I were kind of in the back room here. I think we coined a new phrase, a kind of industry term, if you will. But Kevin, maybe you can expand a little bit on this new industry term that we've formed called enhanced hyperconvergence, and what that means.
Sure. Thanks, Jason. So when you look at how where the world is going with infrastructure, everybody wants this easy button, this on-demand button where we can put rack and stack, push a button, and your infrastructure scales. So if you look at companies like Nutanix and SimpliVity, they've created some amazing products out there that give you this capability. However, this linear approach isn't always the perfect approach to scaling your business. When you look at the CyberRange, they have thousands and thousands of environments and thousands of machines that they use. Some of these are very small environments. Their stack might be a tremendous amount of storage, or I call it high-speed storage, or a flash array storage, where you're going to scale out all that infrastructure underneath, but you don't need that much compute on the top end to virtualize what you're doing. In some other use cases, you might not need as much storage. You might need more compute because you have a fairly large audience that you're replicating something over and over again. So we look at this enhanced architecture. So one of the first things we did is we looked at, as an operating system, how we can offload our processes to an all-flash array, where we could boot from that all-flash array, and we're basically robbing Peter to pay Paul. And what I mean by that is, I want to offload as much as I can to this flash array and take that entire compute and use that as my virtualization cluster. So I'm not competing for resources. So that's the architecture we ended up coming. Actually, ManTech created that infrastructure, And the way we designed it, we can boot from SAN, do inline deduplication back into the SAN while we're preserving that compute cluster for the hypervisor. One last piece, which I really haven't talked about, which is the infrastructure containers. Jason, I want to bring out a little example so you know what we're talking about. And how many of you have heard of a K-cup machine or Keurig machine by a show of hands? Okay, you're the first one who threw your hands up, so you get one of those K-cups.
Free cup of coffee, that's great.
And look, the K-cup machine was an amazing thing for all of us because we can get our single cup of coffee that was delivered for us, and he might have wanted decaf, and he might want the dark one, and I might want the dark one. So at the end of the day, we could come in and not waste an entire pot of coffee, let it get cold. We want to go in and customize this. Now, where Keurig is gone, which is amazing, is they now do soup, they do tea, they do coffee. And the way we looked at the world of serving up infrastructure was, how do we abstract that entire infrastructure layer and convert it to software? So what we've done, we figured out how we can create this software-defined way of creating these repeatable containers, locking them up, and then giving people permission to get inside those. So, Jason, that cup of coffee is yours. You have the permission to get into it. The same thing for others. Each one of you has permission to use these. What's cool is it's a repeatable process, but it can be customized for each one of our customers. So think of a big Starbucks store. Instead of having a long line for the barista, you can now have basically anything you want in these little K-cups. You pop it in and you get this instant infrastructure. That's our philosophy. We believe that this modern approach to infrastructure is going to change the world because we don't even worry about that hardware layer. That hardware layer just becomes a tool, kind of like the flash array being the espresso machine or the K-cup machine. We're popping these pods in and you're serving up that infrastructure. And I kind of look at Ernest as the barista who's behind the scenes trying to serve up this coffee for everybody. Very fast, on-demand, and customized. So that's kind of our logic behind how we built our operating system.
Yeah, and I'd like to give the audience a use case I think pretty much anybody here will identify with. I assume almost everybody here is familiar with the Doden, enterprise services, et cetera. Typically, at the cybersecurity range, one of our mandates is that we're operationally realistic, and that is recreating the Doden, the MPLS cloud. So we can take, or what I did was I took an entire MPLS cloud, I built it virtually within this hypervisor, and then instead of having one MPLS cloud, I can copy that 10 times, 20 times. I can have 20 MPLS clouds because it takes everything with it. It takes the network, it takes everything, and it recognizes that as a single file. What I did actually for our customer was I took that exact same file, put it on a thumb drive, gave it to them, they go back to DISA and put it in, and boom, they have the entire cloud that I built out. That's just kind of a way in which we can do it. You can see how that would ease or make our job so much easier as a cybersecurity range.
I'm going to add one more thing. So what they did, which we had no idea how far they could take our technology, they came to us with a use case where they wanted to virtualize a naval destroyer. From soup to nuts, 5 different classifications of networks, about 1,600 different devices, completely virtualized. There are some components that couldn't be virtualized, so with the software-defined fabric, we basically connected the encryptors, but we took an entire destroyer and shrunk it down onto a single blade server, and now they have 60 virtualized destroyers for about 90% reduction in the cost of a real naval destroyer, and now this year they've actually started working on virtualizing the entire naval fleet so they can play war games. And that it just could never have taken place before. Flying people to a physical location, getting people hands-on into it, it just hasn't happened in the past. So that's a unique use case.
Yeah, you talked about the MPLS networks and one of the challenges of kind of developing an architecture or an environment that mimics or is a replica of that environment. And I imagine one of the challenges would be budget constraints because what the DoD has to build a physical environment or a network, that they have billions of dollars to invest over time, over the last decade. You didn't necessarily have a budget that size, I would assume, in terms of billions, more like millions,
Yes.
to invest in replicating that infrastructure. Maybe you can chat a little bit about some of that, some of
Yeah,
those
that's
challenges.
a challenge for us. The licensing models, except to get to that, is a big challenge. We're doing JRSS training right now. JRSS is a big deal. We're doing tools training. It sounds really good to have 30 students, 50 students, and give them all Fidelis, give them all riverbeds, but every single one has to be licensed, right? So, and you want to be honest, because with the product, it's easy to be dishonest and just start copying things. So yes, it is a strong challenge for us. We're trying to find ways to work with vendors, et cetera, to get a licensing model that works for the government, works for this platform, it keeps nothing on untoward at that point.
Yeah, Kevin, you want to expand a little on that?
Well, I think our time's up, Jason.
Yeah.
So I'm gonna do a wrap up here. I think, the future looks extremely bright because at the end of the day, we're trying to simplify how we deploy compute network and storage. It's extremely complex. I think that creates the cyber threats that we're dealing with today. I think as we simplify things and the compute grows, the intelligence grows with these platforms, we're going to make some huge changes out in the market.
Good. I want to thank you and Ernest both for participating today in our panel, and thank the audience for your time and attention. Thank you.
Thank you.
Thank you.